In this video, I'm going to show you how to analyze data from a transverse wave in Logger Pro. So the first thing you got to do is open up Logger Pro. You're going to go to the Insert menu, and you're going to choose Movie. And now we have to navigate to the movie. I actually put mine in my Dropbox file for physics, and I called it the Fast Wave. So you want to find your movie. It might be in the Downloads folder or in your Dropbox folder. Once you find it, click Open, and there it is. Now I'm going to reposition mine a little bit and make it a little bigger. If your movie is the wrong way, you want to open it in QuickTime first and then reorient it so that it's going left to right instead of up and down. Okay, so here's my movie. Now I'm going to click on this little button in the corner with the red dots to give me my toolbars. The very first thing we're going to do is I'm going to scroll through the movie a little bit until I find a nice example of a wave with the complete wavelength. So if I just hit the fast forward button, I can scroll screen by one screen at a time and see if I can find one I like. There we go. So here we have a beautiful wave with one complete wavelength. So now that I have that showing on my screen, I'm going to set the origin. So the origin you want to have at the equilibrium point of your wave. So you want to reposition it if you need to so it's right in between the crest and the trough. Actually, mine's a little high. I'm going to move mine down just a little. Okay, so there you go. Let's set your origin. I'm going to put my origin here so it's at the point where my wave crosses it. You could also set your origin here so that the cross there is over by where the hand is. It's up to you. All right, the next thing is the scale. Now we use the meter stick to make it convenient. So you're just going to click on the next tab down, which is Set Scale. Try third time's a charm, right? Gotta get all the way over to the other. There we go. Now I have it. So what that does is that's saying that that distance on the screen is equal to 1 meter. And if you see there, that's the standard one, and the units are meters. Hit OK. All right. Now I want to measure the wavelength using the photo distance tool. So I'm going to click on that. And now I want to measure one complete wavelength. So you can use from one crest to the other. You can measure one trough to the other. Or you can measure the point where it crosses the equilibrium. That's what I'm going to do for mine. You can do it any way you'd like. It should be the same no matter where you measure it from. Okay, so there's my measurement from the equilibrium point, and it's measuring one complete wave. Now if I did the same measurement, from the from one crest to the other, I should get the same measurement right there. Well, it's really hard to see if that's exactly the crest. Okay, so that's how you measure the wavelength. And the wavelength is in meters. The next thing we want to do is we want to measure the period, which is the time for one complete wave cycle. So first thing you're going to do is you want to take note of this number right up here. That tells you the time at this frame. So you want to write that down or put it in your data chart. And then you're going to scroll forward and wait for one complete wave cycle. So here I go. So I'm going to wait until the wave gets back to that same equilibrium point. There it is. So the way I did that was I watched the equilibrium point here, where the cross of the origin is, and I scrolled forward until the wave came right back, cycled completely through to that same point. So notice that my time has advanced. So now the time is 1.166. So if I take the difference between the original time and this time, that gives me the period for the wave in seconds. And then you can record that in your data chart. Now, frequency you can't measure directly because, well, you can, but it's a little bit harder to measure. But luckily, we can just calculate that because the frequency is equal to 1 over the period, 1 over the period, so that you can just calculate frequency based off of the period of the wave.